Hi dears, welcome to my channel. Today I am taking class 7 ninth lesson motion and time. What was the 8th lesson? It was reproduction in plants. There we have said about the reproduction, how the reproduction is occurring in plants and various types of reproduction, all the things we have discussed, isn't it? There I have asked you 3 questions also. It's a time to answer these questions. Let's see. The first question was, a flower having either male or female reproductive part, such a flower is called dash flower. The flower which is having either male or female reproductive part, that flower is called dash flower. Answer is what, ma? Unisexual flower, isn't it? Okay. Second one is, fusion of male and female gametes is called dash. It's an easy question, right? Fusion of male and female gamete is called what, ma? It is called fertilization. Stamen contains dash and dash is the third question. Stamen contain anther and filament is the answer. Okay. That part has been over. Now we are moving for the 9th lesson. Up to this extent, we were discussing what, ma? We were discussing biology. Now you are going to enter in the world of physics. Welcome to physics, ma. What the lesson is? Motion and time. It's a simple lesson. It's very simple lesson, and here we are discussing only the basics of the physics about the motion and the time, types of motion, how the motion and times are related, and how can we represent it in graphical way. All these we are discussing. Okay, ma? Let's go what the thing is. Okay, ma? First one is motion. What is motion? How can you say a body is in motion? When the body is changing its position with respect to time, we are saying it as motion, isn't it? See, for example, a tree. In morning 6 o'clock, the tree is in that place. When we are seeing the tree by 7 o'clock, then also the tree is in the same place. Like that, whenever you are seeing the tree is not moving or changing its position. So we are saying that the tree is in rest, or tree is not able to move. But what your case, you are constantly moving, right? Because you are changing the position with respect to time. So we are saying it as motion. Okay, what are the types of motion? There are various types of motion. When you are moving in a straight line, it's a kind of motion. When you are moving in a circular path, it's another kind of motion. All the kinds of motion we are going to discuss. First is rectilinear motion. From the name itself, it's like a line. While you are going for the assembly, you will be in line, right? If you are moving in a straight line, we can say it is rectilinear motion. The motion of the object in such a way that the body is moving in a straight line, it is called what, ma? Rectilinear motion. Then the second is circular motion. When the body is moving in a circular path, we are saying it as circular motion. For example, when the child is sitting in the merry-go-round and if it is running, the child will be moving in a circular path, right? So it is called what, ma? It is a circular motion. Okay. Third one is rotational motion. What is the difference between circular motion and rotational motion? When you are turning around by yourself, it's a rotational motion. For another example, we can say spinning top. It is rotating by itself. Top spin you have already seen, right? You may have played this top. So if the top is spinning, it's a kind of rotational motion. Or the earth is rotating on its own axis, which results in what, ma? Which results in day and night formation. So when you are spinning on your own axis, it is rotational motion. If you are moving in a circular path, it's what, ma? Circular motion. Then periodic motion. If the motion is repeating itself after a regular interval of time, we can say that it's a periodic motion. For example, when a child is swinging, the swing is in periodic motion, isn't it? It is repeating the same thing. Or we can say the pendulum is moving in this kind of periodic motion, isn't it? In this periodic motion, there is one more type, that is oscillatory motion. If the to and fro motion from a fixed point, if a body is in a fixed position at one end and the to and fro motion is there, we can say that it's oscillatory motion. To say periodic motion and oscillatory motion are moving in a same line, still we are saying it as oscillatory motion. For example, if we are walking quickly, your hands will be moving. It's a kind of what, ma? It's a kind of oscillatory motion. Isn't it? Like that, if you are thinking, you will get some answers. Or to say, when a child is sitting in a seesaw, it will be moving up, coming down, moving up, coming down. It's a kind of oscillatory motion. Like that, the motions, types of motions are like this. Okay, now we have to say about time, because up to this extent we have said about motion, what is motion, types of motion, all this we have discussed. Now about the time we should say. What is time? Time we will say what is time. This time. This is our time, isn't it? Actually, what is time? Time is the moment or duration in which a particular thing occurs. To say your exam, you will say from 10 o'clock to 12 o'clock exam is there. It's a duration, isn't it? So the duration is what, ma? We are saying it as that particular time. Okay. So this is kind, we will say, explain about the time. Okay. This is a kind of explanation about the time. And time is, time also will be repeating again and again. How can we say? The sun is rising every day in the morning. And sun is setting every day in the west during the evening time. So we can say from the sunrise to sunset, one day is there. A day is between the sunrise and the sunset. And from sunset to sunrise, a night will be there. Isn't it? Okay. So, dears, in ancient times, the people didn't have clocks like you are having. So, how did they calculate the time? By seeing the shadow, they used to calculate the time. In the noon time, when the sun is right above us, the shadow will be minimum. When it is evening time or it is the morning time, the shadow will be much more longer. By the time they were able to calculate, oh, it is 8 o'clock, I think. Or it can be 9:30, like that the time will be. Like that they were able to calculate. Okay. Sundials was the ancient time people used. Okay. Or by some other way, that is by using sand clock. Have you seen? Two semicircles and two semicircle glass bars, and in that the sand will be seen present in one side. When the sand is fully present in one side, they will turn it upward down. So it will take 1 hour for the sand to fully come down. Okay. By the time they calculated, 1 hour is over, 2 hours is over. Like that they used to calculate. It was the olden method for calculating time. But now we are blessed with clocks and all kinds of facilities. In the mobile itself, all the time will be seen. Not only the time of India, to say, the time of the entire world can be easily calculated, isn't it? So just I will go as a quick, all the things you know, that is 60 seconds make 1 minute, 60 minutes makes 1 hour, 24 hours makes 1 day, isn't it? 1 day means 1 full day. And then how many days becomes 1 week? 7 days makes you 1 week. And to say 52 weeks makes 1 year, or to say 12 months makes 1 year. And how did they calculate the month, you know? From one full moon day to other full moon day, they calculated as 1 month. Okay, it was the ancient method. Okay, how many months are there in a year? 12 months, as you told. Or to say 365 days makes 1 year. Like that the time is expanding, isn't it? Okay. So now you understood about the motion and the time. Now I am having a doubt. Is the motion related to time? Of course. How? We can see. Let's suppose your house is 5 kilometers away from your school. Okay. 2 children are there. One child is going every day to school by a cycle, and the other child uses car to go. Okay. So when both the children started at the same time, the second child who is going in the car reaches the school within 5 minutes. Okay. But the first child who has to ride the cycle reached by 15 or 20 minutes almost. So we can say the first child reaches slowly, but the second child reaches fastly, isn't it? How can you relate them? Because we can relate with respect to time. Why the second child is fast, which you are thinking? Because within 5 minutes she reached the school. Why the first child is late? Because it took 15 or 20 minutes for her to reach. Understood? So we can relate the motion with time. Yes or no? Okay. So by this way we can relate the motion and time. So we can say slow motion, fast motion, all these are related with time. Okay. So when we are saying slow and fast, we will say she came fastly because her car is having much more speed. Will you say? Speed of the car is more than that of the cycle. That's why she reached. What is the speed? Speed is also the same thing. The distance and time, when you know, it is easy to calculate the speed. So what is speed, Kana? Speed is total distance divided by total time. The distance covered divided by time gives you speed. Why the car is having much more speed? Because the time taken is very less. You have learned, you are very expert in maths, right? So you know that when the denominator value is getting decreased, the answer will be much more increased. Yes or no? It's a trick, right? Here time is 5 minutes for the person who is coming by car, and the time is 20 minutes for the person who is coming by cycle. So by the time you can understand, even though distance is same in both the cases, as the time is changing, the speed also will be changing. Okay. So what is speed, Kana? Speed is the distance traveled divided by time taken. Understand? Based on that, much more numerics will be coming. Can you say, if the same thing, 100 kilometers, the distance I have changed, 100 kilometers is there to cover, and a car and a bike are the two racers. Okay. Within 1 hour, car reached. Within 1 hour, car reached 100 kilometers, but the bike took 2 hours. Okay, what is the speed of the car? 100 kilometers divided by 1 is equal to 100. 100 kilometer per hour is the speed of the car. But in the case of bike, it is 100 divided by 2. It's what, ma? It is 50, isn't it? It's 50. 50 kilometer per hour is the speed of the bike. Understood? So we can compare whether the speed of the car is more or the speed of the bike is more by calculating this way only. Distance divided by time give you the speed. Understood, ma? Okay. When we are saying about the car or bike or whatever it is, have you seen something which is in circular in the dashboard? Have you seen something circular or half circle like that? Half circle like that. In that something has been written. Have you seen, ma? It will be like this. And it will be written 80, 100, 120, like that it has been written. Have you seen? And there will be a pointer also. This pointer goes on changing while the vehicle is moving. Or it will be fixed on 100, so to say 100 or 120 like that in the case of car, or even in bikes also. So what is it? What is it? It's a meter. It's a meter which helps for recording the speed. It is called what, ma? Speedometer. In almost all vehicles, the speedometer will be fixed, so that we will be able to understand in which kilometer per hour the vehicle is moving. So it is called speedometer, Kana. Not only that, below it there will be a rectangular box. Have you seen? A rectangular box will be there, which some digits will be seen on it. And when we are starting, there will be a digit, particular digit, and when the car is coming to an end, the digit will be changed. Actually, it's a meter. for recording what? The distance. If you are seeing, as you are children who are much more curious to know things, if you are entering in the car, just see what is the reading in that box. Actually, that box is called the odometer. What is the reading? You should have to write. Okay. After, when the particular distance has been reached, the car will be stopped now, right? By the time you again see what is the distance now, or what is the reading now. If you are subtracting the initial value from the final value, you will get what? The distance. You will get a number now. That number indicates this much distance the car has been travelled today. Okay, this is what ma? This meter for understanding or recording the distance is called what? It is called odometer. What is that ma? It is called odometer, and the meter which is used which is helpful for recording the speed is called what ma? Speedometer. Okay, both two meters are there kana? Odo, speedo. Odo for distance measuring and speedo for speed measuring. Okay, now we were discussing what ma? Up to this extent we were discussing about the speed. Now I am having a question. What is the unit of speed? What is the speed actually? It is the distance travelled by time taken, right? So the distance can be either in meter or in kilometer or in some other higher measurements of meter and all. And the time also can be in minutes, in seconds, or even in hour and all. So the speed is having various units. To say the speed can be written as speed. The unit of speed is equal to kilometer per hour also is correct. Kilometer per hour is also correct. But SI unit of speed is meter per second. Okay. Why I am giving you all these instructions is, when the question is asked, you should understand that whether the distance is in meter or time is in second, then only it will be easy for you to calculate the speed and the answer will be correct. If the time is in minutes, you have to convert it into seconds for calculating the speed. Okay, that's why I am giving stress for these terms. Okay. Now we are moving to see about the uniform and non-uniform motion. What is uniform motion? Is a motion wearing uniform? No, it's not that. Actually, uniform motion is when a body is moving in a fixed path without changing its speed. We can say that it's in uniform motion. How can we understand whether the object is in uniform motion? For example, our car. From the beginning of the class itself, I am going on with the car, right? So the same car. We are riding in the car. There we have seen speedometer, odometer, everything we have seen. Now again the same car. When the car is moving in a traffic-less road, if it is moving in a traffic-less road in 100 km per hour, we can say the car is in uniform motion. The speed is not changing, isn't it? The speed is not changing. It's fixed and it is moving in a fixed speed. So we can say it is in uniform motion. Okay. If the car has entered in the traffic road, it has to be stopped for some particular time. It has to move very slowly. Again, if the traffic is getting less, it will go a little more fastly. Again, when the traffic is coming, it has to be slowed down. Like that, the car will be moving. So we can say that the car is in non-uniform motion. Okay. Understood about the uniform motion and non-uniform motion? When the object is moving without a change in the speed, or the motion is moving on in a straight line without any change, it is said to be uniform motion. When there is a change in the motion, we can say it is said to be the non-uniform motion. Okay. Now all these things you have understood. Now how can we represent it quickly, easily? We can represent it very easily with the help of a graph. Graphical representation. Graphical representation. Is the graphical representation have any help? Yes. It helps to determine the position of the object at any point within the time interval. Okay. Consider the object or our car again. 0 time 0. When it reaches 2 minutes, if it is moving 2 as the distance, 2 kilometer to say 4, 4, 6, 6 like that if it is moving. This is the time and this is the distance. Okay. So, here the distance will be. In the y-axis distance can be represented and in the x-axis time can be represented. So, starting will be 0, 2, 4, 6, 8, 10. What is that, ma? Time. When you are representing the graph, you have to mention what is that in the x-axis and what is that in the y-axis. Otherwise, what? Your marks will be gone. Okay, distance 2, 4, 6, 8, 10 like that. It's moving. What is this, ma? This is the distance. Distance. Okay. Then how can we represent when 0? 0. When it reaches 2, it will be in 2. Isn't it? When it reaches 4, it's in 4. When it reaches 6, it's in 6. When it reaches 8, it's in 8. Like that it's moving. So when these points, when we are joining, we will get what, ma? We will get a straight line. We will get a straight line. So what do you have understood from it? You are understanding something. That is the object is in uniform motion. The object is in uniform motion. That's why we are getting a straight line. Okay. When the same object is in non-uniform motion, how will be the graph, Kanna? The graph will be like this, either, or like this, either, or like this. It will be uniform motion. So you have to understand one thing. When the object is in uniform motion, the graphical representation will be straight line with moving upward or moving downward. Okay, whatever it is, it will be moving. But when the object is in non-uniform motion, it will not be in a straight line. So, let me ask you one question. What will be there when the motion object is in rest or the object is not in motion at all? Here again time. Here distance. Okay? If it has start, if the object is in rest, it will be straight line. As the time is changing, is there any change? No, because the object is in rest. The position is not changing with respect to time. As I told you in the beginning itself, it's not changing its position. So what happens? It's in rest. It is parallel to x-axis. It will be parallel to my x-axis. Okay. This is all about the lesson. I think I have made it easy for you to learn. Now I am not going to leave you at the question. Are you ready, Kanna? The first question. Motion of a horse pulling cart on a straight road is which kind of motion? Motion of horse pulling cart on a straight road. It's a kind of, which kind of motion? Okay. Second one. Distance between two stations is equal to 240 km. Train takes 4 hours to cover the distance. What is the speed of the train? That's very easy question, Kanna. The question is, distance between two stations is equal to 240 km and the train takes 4 hours to cover the distance. So what is the speed of the train? Third one, again for you, motion of the hammer of an electric bell is dash motion. Motion of the hammer of the electric bell is dash motion. Okay? Only up to this extent I am taking the class and we can meet in the next class.